All right, CNT140, we're on Chapter 8. We're talking about the support structure. We just got done talking about tray sizes and making sure we have adequate room in them. One of the next things they mention is bend radius. So as we're installing our cabling, we need to be thinking about minimum bend radius. If we bend it too tight, if we bend cabling too tight, the wire twists in there, we deform those so that the cancellation may not be happening in that little point in time, and I'm going to get interference at that little, where that bend is. If I keep bending, I might actually damage the cable inside. So they're saying, hey, when we're installing cabling, we need to have a minimum of, and they talk about 4 times the radius of the cable. So in other words, a nice big bend. The bigger and the more gentle, the better off it is for the cabling. We need to also worry about when we're routing cabling, we're staying away from power lines, lights, that sort of thing, ventilation motors, that sort of thing up in the ceiling, so we don't pick up that interference and noise. Our premise support structure also include patch panels. They can be mounted, rack mounted, wall mounted in our system. We also want to remember that our patch panel on the closet side is getting terminated with our solid cabling, just like the outlet on the other end. Our solid horizontal cabling is getting terminated into those. And in our closet, that's where we have rows of patch panels, usually 1 per switch, if you will, kind of thing. But our patch panels might be in a small cabinet anchored to the wall or ceiling. We also need to worry about, they talk about fiber optic connections. Fiber optic connections, they talk about certain types of fiber. Some of our fiber can be in an open panel, but some of our like 900 micron tight buffered fibers, the kind we are going to end up using later this semester, need to actually be in some kind of support or closed termination patch panel. This whole thing slides into the rack and is covered and supported. So depending on the terminations, I might need to worry about a different type of patch panel. As we're terminating, we're thinking leaving a service loop. So cabling coming out of a tray or into a closet, I leave a, kind of a figure 8 or a loop here before it goes down into the rack. That way I have space in there in case I need to move a rack. Things like that, I have room to do that without having like cut cabling free. So they call that a service loop. If possible, make sure there's adequate space provided for terminations. Well, I put a picture of a diagram of a typical telecom room showing that I need to make sure there's room, a large door to get equipment in and out. My equipment rack should be kind of in the middle of the room so I can get to both sides of the rack. And that's what they talk about, make sure there's adequate space provided for terminations. And that even goes in for as far as the closet layout is concerned too. Any cabling going through walls or floors they're typically going to go through a piece of conduit after you put a hole in the wall or floor. And after that is done, you need to worry about fire stopping. Using that material in that opening. Here's some fire stop here, here's some fire stop here, here's a mechanical fire stop, to try to keep, if there was a fire in this room, burning right through here and moving into another room. That's the idea behind that. Our standard 569 standard has a section on fire stopping. What's required, what's needed. They talk about electrical systems. We'll need proper power at our locations of equipment. The power should be conditioned for surges and spikes. That's why a lot of times the power coming into a room goes through an uninterruptible power supply, and then all the devices, your switches and so forth, plug into that uninterruptible power supply. And that uninterruptible power supply is then acting as a filter to get rid of the surges and spikes and giving off clean power to the devices in the rack. And also there, in case power to the closet is lost, that battery backup unit is already powering the equipment in the rack. We should have a separate ground to that closet, not shared with other motors and things that are kicking on and off and potentially leaking electricity, if you will. And we should have adequate air conditioning for the equipment in the closet. Again, 569 standard has all kinds of stuff about our building specs. This is the environmental and so forth for electrical, HVAC, etc. in our closets. They mention again about grounding and bonding. I should make sure that any of my metallic trays and racks and so forth are bound and then grounded. So we're talking about, as I have links of, trays, I need to bond them together, and then as it gets to equipment rack, that's bonded to the equipment rack, and then that ground wire, that bond wire, goes to a ground bus that's connected to a building ground for that closet. So there is stuff in the standard about how that is done, but that's when you start seeing these wires connecting trays together or equipment to a rack or a bus bar in the bus ground in the rack. That's what's going on. Again, your standard 607 standard has a section on grounding and bonding of your equipment. Marking and identifying, yes. All your cables, all your jacks, all your outlets should be marked so that we know what it is for, and you might even go through and use a color code for it. I can be using color codes on cables, labels, ports. I can even do out of my face plates. I have labels here. I might even be able to color code my outlets depending on the function of that port. But I need to have some sort of way to document all this and document every piece. 606 standard, TIA 606 standard, has guidelines on how we document things. The scope of this standard lists here about, hey, the purpose of this is to assign a scheme for infrastructure labeling, etc. 606 standard talks about all that documentation. They remind us that cable jackets should be specified with cables should be specified with colored jackets for fiber optic. We're really talking about to indicate the type of fiber in the cable. So reminding you when we talked about fiber optic, the different categories of multi-mode cable on 1, 2, 3, 4, 5. The jacket on the outside will be a different color, and that'll be a clue as to what type of cable that is. In addition, the connector should also be color-coded to identify what it is. This connector here lets you know it's an OM1 connector. This one lets you know it's an OM2, and down here we have an OM3, and so forth. Then I can look between the cable and the outlet to know what it is. All fiber optic connections should be tagged and labeled and identified as well as what it is, where it's going. If I look at the closet here, again, what is this? Where is this cable going? What is its function? And if I even look at this cable here, we have the yellow jacket and blue connector body up there. So if I look at that guy, I know yellow jacket, that's a single mode cable. Blue here, we see that is a blue body here. That is your single mode connector as well. Here they remind us about once upon a time 62.5 125 was the primary fiber for premise cabling. As we move along bandwidth wise, the laser optimized 5125 has become more popular. So a lot of your systems are now using that one. You need to make sure you don't intermix them or connect those two together. That'd be like taking two garden hoses of different sizes and trying to connect them together. The bigger one to the smaller one, water's going to squirt all around. And here, that's exactly what it's telling. Mixing those two, you're going to have excessive loss at the connection, and it might not even work properly. So again, go to the color code of the jacket, go to the color code of the connector to make sure you're not interconnecting those two. And I put a reminder here about your connector types as well. SC, ST, MTRJ, LC. A lot of modern connections are using LC. Just as a little heads up. They remind us about removing and recycling cable. It may be required to remove unused cable by the electrical code, but again, as we said earlier with the contract, you need to make sure the customer is not needing that, it's not there for future use, verifying, and then verifying it's not actually hooked up to anything before removing. And I put a little thing in here this is from the National Electrical Code about abandoned cables. This requirement talks about removing the accessible portion of abandoned cables that are not identified for future use with a tag. So any cabling that would be here above the ceiling, this bundle right here, it's actually tagged. It says for future use. But if it were not tagged, it'd be like, okay, is this going anywhere? Is this needed for anything? Because we're required to remove it if it's not being used or hooked up to anything. And it's also about the accessible portion. If this cabling's down through the wall and I can't get to it, well, then I can't actually remove that. All cables should be recycled properly. There is actually organizations and recyclers that will do that. The copper inside has some significant value, and even some of the jacket, some of the plastic jacket has some value to it as well. So they talk about when you're maybe pulling cabling out, separate into different piles, power, data, etc., and maybe even by cable jacket. That way it's easier to recycle bundles of things. Don't try to remove the jacket, leave it all intact, but do remove any non-cable scrap connectors, cable ties, that sort of thing, and then try to find legitimate or certified recyclers to process that. Okay, now we're actually moving on to installing cabling. Reminding us that cabling can be installed in many ways. Underfloors, conduit, J-hooks, walls, inside walls, special cable trays, built-in modular furniture, etc. Installations might need to be tailored to the property based on what the needs of that facility are. So there might be a combination of things in there that gets used for installing the cabling. Mistakes in install can affect the actual final performance of the cabling. In some cases, it might be difficult to identify. It is possible a mistake could keep the whole system from working. So again, a good design, proper install will help ensure that is hopefully not the issue. The standards were created for universal performance standards for the manufacturers of the cabling components. So the manufacturers might do things differently. The standardized components are supposed to be interoperable, but they might not have the same install requirements. That's one of the reasons some contractors will stick with one brand of outlet jacks, patch panels, etc. That way things should be all the same, work all the same way, if you will. But it really is up to the installer to understand the installation procedure from that manufacturer. How do I install this particular jack and so forth? Proper install depends on your proper design. Again, pathways, spaces, etc. for installing all this. Having a good design, the things are installed properly, and things should work from the get-go. Where the cables around the building are important, cables need to be kept dry and in moderate temperatures, not too hot, if you will. Too hot and the cabling might have data loss or signal loss. Any supports for our cabling should be wide enough, strong enough. We mentioned that before. We should be wide enough that we have room for, and actually room to potentially add cabling later. And the supports for that need to be spaced enough that you're not going to have the tray buckle or twist or anything like that. Reminding you of the manufacturer. Manufacturers have tables about how much load a particular tray can carry or how many cables can fit any particular tray. And you're usually thinking what you need now and down the road. So trying to make sure you have oversize or over width for future growth. Cabling should be installed with cable trays, J-hooks, those sorts of things, paying attention to bend radius. So again, cable trays, J-hooks, there's J-hooks of different size that can anchor to the wall, can also anchor to steel structure above the suspended ceiling, okay, that kind of thing. Interduct for fiber optic, raceways for cabling coming down the walls. All those things are available to route the cabling to where it needs to be and be protected. We should be paying attention to bend radius. Again, as we're installing cable, nice gentle bends, making sure we don't have a tight bend around a corner that'll deform the wire twists inside the cable and potentially cause interference or noise at that bend. Again, they remind us we should not be laying cable on top of ceilings or ceiling gridwork. So as I look at a suspended ceiling here, a false ceiling, drop ceiling, suspended ceiling, as I move these tiles out of the way, this gridwork is up here to support that. I am not laying my cabling on this gridwork. I'm not laying my cabling on top of these tiles. The weight of them could break through, or as people get through that ceiling to work on things, the cables might get damaged. And they also remind us I can't anchor those cables to these wires that hold up the grid structure, but I could make my own cable from the ceiling to anchor onto. That can be done. All right, when we come back in the next one, we'll continue on.